How are you? My name is Piyush. Yeah. Uh, what's yours?
Yes. My name is June.
Okay. So
Nice to meet you.
nice to meet you too.
It seems like I'm the interviewer first, so do you want to take a couple minutes to read over the problem? And
Sure. Yeah.
yeah,
So I have to find a root of number. Many times we need to re-implement basic functions without using any step. For example, when we design a chapter, so there's root of the number. The function takes a non-negative number x and a positive number n and returns. mm, Yes, positive is positive. Y minus root. Okay, so there should be this. Don't value. Okay, so I think what the question here needs me is to get the nth root of the number, and where n is always greater than 0 and x is always greater than equal to 0, and
hmm
the error should be in between 0.001, within the range of 0.001.
yep.
And yeah, so is there any upper limit to n or x? That is something what is not given here.
Um, yeah, I don't think the problem really specifies it, but I can probably assume it fits in a 32-bit integer.
Okay, so the x can fit in 32-bit integer and n also.
Well, I guess yeah.
Okay. So what I'm thinking here is basically what I can do is I can use binary search here, right? So because I have to find the nth root of the x, right? So I can guess a number between 0 to n and check whether it is the nth, like if I do the power of that number, whether it is equal to my x or not, and if it is equal to x, then that will be my answer. Or if it lies in the if I do the negation of both, and if the error lies in between 0.001, then also I can return it as a probable root of that, or as a root of that particular solution. So in this approach, I think it should the complexity would be like order of log n, because I will be doing a login operation
Okay.
to find
And
that number.
what about space complexity?
So the space complexity will be like order of 1.
Okay. Yeah, your approach sounds good to me. Do you want to try coding it or?
Sure. So basic algo should go something like this. So my initial range will be in between 0 to x, right? And then
Mhm.
I will pick a number, and calculate power of n, then check the error. If error is less than equal to 0.001, return answer, else continue, right?
Yeah, that makes sense to me.
Okay. So let me just code it down. The one thing that we have to see here is it can go up in the decimals also.
Mm-hmm.
So that is something what I need to check. Because then if I go into the decimals, then there can be like infinite number of choices that I can make, right?
That's correct. Mhm.
Mhm.
Technically, there is infinite number of choices, but we just need to check if it's less than or equal to 0.001. So that I think that check in itself is good enough.
Yeah, but then I have to consider it as an float, not as an integer, right? In the binary search.
I think that'd
Uh,
be a good. Yep.
okay, let's try. Let's see if it works or not. So my low range is 0, and my higher range will be x. Will be x, right? Then I can write a loop where till low is less than high, right? I can calculate the mid. So mid is equal to high minus low. Divide by 2, and this I need to do as float, right? So this will give me the mid number. Now what I can do is nth root, yeah, nth power. So nth power will be something like mid into n, right? So
Mm-hmm.
if my let's say x minus nth power is greater than equal to is less than equal to 0.001, so I have found my answer, right? So return this mid, else. So now I have to make a choice whether I have to increase low or whether I have to decrease high. So if let's say my nth x minus nth power is negative, right?
Mm-hmm.
So if my f, actually I have to put one more check. So it should be in between 0 and 0.001, because else it will satisfy the negative term also. So if my x minus nth power is less than 0, then that means my nth power is very high. So I have to decrease my range from the higher side. So it should be mid minus 1. Actually, yeah, so here it is a difficult case, because if you do mid minus 1, then you are basically eliminating the complete entire range between the mid minus 1 and mid, right?
Yep. Mm-hmm.
So I cannot do this. Okay, let's see. Else low is equal to mid. So this loop assumes like we will get an answer always. because there will always be nth root. So this
Mhm.
condition will hit after n number of times. Um, but actually, I'm not sure whether it will go into infinite loop or not. Because let's say the number is 3 and 4, right? So it will go in loop in again and again within 3 and 4, because low
Right.
will always be 3. But
Right.
if I do something like mid plus 1, then it will become 4 and loop will end. But then let's say the if the root is in between 3 and 4, then I will skip that. So that's the
Right.
issue here.
Hmm. So you have the right idea. The while condition, maybe we can look into that
Yeah.
because, like you just said, low less than high. We're gonna either skip it if we do mid plus one or mid minus one, or if we leave it as it is right now, it's gonna go into infinite loop. So
Mhm.
maybe there's something else that we can check.
What we can check is if high minus low range is less than 0.001.
High
Uh,
minus low ranges. Um, high minus low range is less than or equal to 0.001.
then I think like we have exhausted all the possibilities.
That that might work. I haven't really approached it that way, but that I don't see why that wouldn't. We could try that.
Or what I can do is I can increment in this order, the mid. So in that case, I will always have I will always move forward, even if it
Oh,
is
so
in the
you're
small
saying,
range.
okay, so you're saying high would equal mid plus 0.001.
Yeah, mid minus 0.01,
Okay,
and it should be mid plus 0.001. So in this case, like I will always move forward.
okay, yeah,
But
let's try
yeah,
that.
but this will take like a lot of time. But yeah, let's try to run this and then see if I can do, like, if it works or not.
Sure. What are we returning?
So I'm returning here, right? So mid, if I'm getting here.
Oh, I see. I see. Okay.
So I think it will always be a case like you will get like I'm assuming like I will always get a number.
Yeah. So, do you want to run some test cases?
Sure. Failed. So the input is 27.3. Now in this case, let's do a dry run, right? So in this case, my low is 0 and my high is 27. Now the mid will be 27 divided by 2, which will be something 11, 12, 13, 13.5, right?
Mm-hmm.
So now 13.5 minus the nth power. So I have to calculate like 13.5 to the power 3, which will obviously be negative, right? So it will go into mid minus. So high will become something close. Actually, it's quite difficult to try run here. 0.001, something like this. So let's consider it like 13.5 here itself. So
Mm-hmm.
now my high is 13.5. Now again I will go and calculate the mid. So now the mid will come nearly 6.5, I guess. Like I'm not exact, but something like this.
Yep.
6.5.
6.5, 6.75.
Yeah, 6.75. So now if I do 3 again, it will be a negative number, right?
Mm-hmm.
So now here the high becomes 6.75, and then again I will go and do this, so it will be something like 3.125,
Mm-hmm.
I guess. And
So yes.
then 3.125 will go and it will again be higher than the number, but it will be somewhat closer. But I don't think like it will fall in this range. So now my high will become, now here actually it should, we should consider decrementing it something like this. Now it will be like mid will be 1.5, and its power will be like should fall in this, right? Because it is not less than 0. 1.5 divided ki power 3, right? So it will be something 4 point something, I guess.
Yeah.
So it will be like coming up here. So now mid will become now this will become 1.5. Now again, so now like it should go and come here actually. Actually it didn't return anything.
Yeah. So I think we might have skipped it because expected was 3. Based on your logic, it should hit 3 and return it, but it didn't.
Yeah.
So going back to the while condition, we still have low is less than high, but like logically, how like when should we stop searching? So you said binary search, which is I agree. I think that's the right method to go. But when should we stop searching? So like what's the condition here? The problem states that should be less than or equal to 0.001. Maybe we could use that as a clue to know when to stop the binary search. Or the you're returning early here. So in line 35, 36, you're returning mid as soon as you find it. But maybe we shouldn't return early because maybe there's more calculations that need to be done. So one or the other, I think, or both.
Yeah, actually what we can do is we can store it, right? So instead of returning it, I can store it and I can again proceed.
Okay. We'll try that.
And then I can return the answer. So so what this will do is like if it gets an answer, it will not terminate. It will go again and find for more precise answer.
Okay, we could try that.
But actually, the problem here is like it is not going, so it is actually returning. Now it will go and like it will be TLE because now I have removed this, right? So let me do this if I'm overthinking about. Oh,
are we doing? Don't you want 0.001?
yeah, sorry. No, it's running actually. It will go infinite, yeah. No, it TLE'd.
Okay, so in your logic here, you have line 36, 37, that's an if statement, and then you have an else block. Maybe because if we hit the if statement, we're never going to update any vector.
Yeah. Well, actually, I forgot to update this. Yeah, no, it should. Yeah, actually, you're right. Um, but actually, right now also like it is. Oh, okay. No, it is not hitting three. Actually, I think in my solution. Okay, what I am trying to do here is I am finding mid. Let me just print mid. What it is coming, or let's say nth power. So it came till 3 and then started incrementing, which is wrong. Oh, okay. So it came here, right? To 27,
Mm-hmm.
but it didn't came to exact 27.
Right. So, um, okay. So, what if we have? I'm gonna type it in up here. What if our answer is supposed to be 3.0, but we have low as 2.009, 2.08, and then high as 3.0021. If we have low and high as these two values right here,
Mhm.
um, shouldn't we continue to run this binary search so that we can fall within either two? So that answer could be either 2.009 or 3.001. Those two should fall within the 0.001 condition.
I think the problem here is like I'm going into like long float, right? So I'm not reducing the precision till 0.001. So that's why it's lingering. Like if I do this sealing kind of thing, right, till that precision, then I think it should work because then it will come to 27, right?
Yeah, so when I did this problem, the precision part isn't it. They don't really. It doesn't matter. So
Okay.
you're okay on that. Is so I just want to revisit line 32.
Okay.
So while this is the correct way to do like a normal binary search, this problem does require a different um, condition that we have to keep checking. Do we need mid to be within? Do we need to initialize mid in the while loop? Can we do it outside and then maybe use that to use our while condition?
So, but actually, if I put mid outside,
Hmm.
and okay, so you are saying like we should also check if my mid and low, if I put my mid outside, right? So the first time I calculate the mid, it will be quite high. And what should I check then? If my mid की power n. So sh- I should check this condition also here.
So in the problem statement, in this the second paragraph, the last sentence, that's a big clue right there. So, or yeah, the function takes a non-negative number x and a positive integer n, returns the positive nth root of x within an error of 0.001. So the last statement here, suppose the real root is y, then the error is y minus root xn and must satisfy y minus root xn less than 0.001. So if right now mid should be the the answer that we want, right? So in this case, y is mid. And so based off the statement there, what do you think should happen?
Yeah, because error can be like in the negative side also. So I've put the ABS here. Um, and then if I'm trying to do this, and then I have to recalculate mid also, right?
Yeah, so here if we want to do it this way, we can update mid. Yeah.
Alright.
Yeah.
So now what I'm trying to check is I am trying to run my loop till my error is in between this range, and my low and high will basically yeah. So now my low and high will basically have the same conditions, but the loop will only end if my error is in between this range.
Yeah, we could try that. Let's try running some tests on that.
No.
Okay, so in a normal binary search, what's the so you had it right earlier. So this is the we usually do this for normal binary search.
Mhm.
We don't need high for this particular problem. So sorry, I don't want to give out too big of a hint without like telling
Okay.
you the answer. So I do think we need to incorporate like one of the bounds. So I don't think we need high, but let's see.
So my mid cannot go less than low, right?
Yeah, it
And
can go less than low. So
and yeah.
yeah, what should be the bound the like the cushion between mid and low? Like what should it never go to? You almost have it in the this while statement right here. It's very close, but not quite there yet.
Mm. Okay, so if I have my low, so what condition should I put on low? So the low should the low and mid, right? What is the relation between low and mid? Uh, Yeah, actually, I'm unable to think like how, because like in this boundary condition, right? So I'm still moving my low and high based on this calculation, A B, like this one. But I am checking till this error, basically this error. But problem here is, I think like this statement is not hitting, because while this condition comes true. Oh, okay. Actually, the problem here is it should be in reverse, because if this is true, this is not true, then only I want to run the loop, right? And if this becomes true, then I should exit. So actually, it was wrong before, right?
Okay.
Um, and then in this case, but the problem here will be ki if let's say my this condition like hit, right, but then there can be another better case. For example, I have like 3.001. This will also satisfy this, but the three is the better answer, right?
I think we can just return whenever we reach that condition. So 3.001 or 3 would work.
Okay, so should I try to run this? Oh, no, it failed everywhere.
Yeah. So you want me to help you out here, or
Yeah,
because
sure.
due to time? So what I was trying to hint at was be checking mid minus low. Down needs to be there.
Greater than equal to 0, 0.
hmm Um, we, so if you just you have nth power, so if power, the if statements that you had were good.
Mhm.
That's the solution here. Um, you're pretty much there. I mean, x. I mean, if you switch nth power over here, you're checking the right things.
Mhm.
It was just, I think, the while condition and um, this part here.
Okay. So if I remove this, and but then in this case, if you're doing it as mid, then won't it go in infinite loop?
No, because we're doing greater than equal to. Usually, if we do like a normal binary search, if while low is less than high, then yeah, we would want to do like high equals mid minus one or plus, or, yeah, minus one, or low equals mid plus one. But um, we don't need to do that here.
Okay. So we remove this. Or you can remove this. Keep this. So this should give me the answer, right?
It should, yeah. Run it if you want. Yeah.
Okay. Okay.
Yeah, binary. It's a little tricky. I had a lot problem with this. A lot of issues with this problem too.
Yeah, yeah.
Um,
I was almost there, but I think this condition
yeah,
I failed to grasp. Okay. Yeah. Nice problem. Yeah. Thank you so much for helping.
yeah. Good job. You're very close.
Okay. Let's swap the rules.
Sure. Give me like a minute or two to just read this problem,
Sure.
and
Sure.
I'll ask any questions. Okay. I'm looking over the examples just to see if I'm understanding this correctly.
Mhm.
Okay. So it seems like slots A and slots B are lists of pairs, and then duration is just an integer that represents what we should aim for. So our output should be the duration given to us.
Mhm.
So if slots A or slots B, if none of the intervals are if if none of the intervals are greater than or equal to duration, then that means that it's an invalid time slot, right?
Mhm.
Okay. So we have that. And I'm assuming all the inputs are going to be valid, so no negative numbers. These are all epoch time, apparently.
Yeah, the constraints are given in the bottom.
Okay. And let's see. Our output should be just a pair from start to finish of when person A and person B can meet together
Right.
based off their input. Okay. And again, it says that okay, the slots are sorted by slots start time. So okay, it's already sorted for us.
Mhm.
All right. So then, um, let's see here. Hmm. think what we can do here is just have 2 pointers, obviously one for slot A and one for slot B, and find the minimum, or I mean the maximum of the start time for both and the minimum of the end times for both, and see if that, well, actually, no, that's not going to work. We should do a check where the 2 time slots are overlapping, and if not, then we increment the lower of the 2 slots to the next pointer or to the next index, and then keep checking. And if they do overlap, then we basically get the max of the start time and the min of the end times, and see if they overlap greater than or equal to the duration. So if you don't mind, I'm going to just type some pseudo code here, or like just jot down some notes. So we have pointer A, pointer B. We check each interval, both A and B. If one interval, if the intervals don't overlap, we increment the pointer of the lower interval. If the intervals do overlap, we extract the min of the start times and max, or I mean the max of the start times and the min end times, and see if the overlap interval is greater or equal to duration. And this is obviously, I think this can be done with a while loop. So if we do this, we do the above while pointer A or pointer B are within their input size. If we have an empty, like let's say we have an empty slots A, but we have a valid slots B, we should automatically return nothing. Vice versa with slots B. Will duration ever be 0? Let's see. I don't think it mentions that. Should I go into that?
Yeah, I don't think like duration will be 0.
Okay. So we can assume duration will always be a valid greater than 0. So let's see. If one of the slots interval lists are empty, return empty list. Okay. Let's see. Yeah, I think that'll cover majority of the cases. If there are any cases, I'll definitely address them. But are you okay with me coding?
Yeah, I think the approach seems correct. So what will be the time and space complexity?
The time complexity will be O of. Let me just type it up. It will be O of max of M and N, where M is the size of slots A, and N is the size of slots B. Space complexity Space complexity is it's constant. We're not using any additional lists to keep data or store data for anything. So yeah.
Okay. Yeah, sounds good. Let's implement it.
Okay. So the bat, I'm gonna start initializing the size for slots A, slots B. So
Mhm.
I'll call them size A, size B. Length of slots A, slots B.
Mhm.
If size A or size B, size A 0, not size A, not size B, we return an empty list. So yeah, okay, we can do initializing pointer A and B. And while pointer A is less than size A and pointer B less than size B. So we're checking the intervals now, so we have to check if they overlap. So okay, so if slots A, pointer A, there should be an easier way to check if it overlaps. So give me a second here. Let me just think about it. So it could overlap in two ways. It can overlap. That's A. And it can overlap that, or so we want to keep track of the start time of one and end time of the other. If it's less than that, but then it's not always the case because it could be like this. There should be at least two conditions. So let's do this. So if the start time of A is less than the end time of slots B, and slots A, pointer A, start time is greater than or equal to slots B, pointer B, or to slots B, pointer B, So basically, I'm just writing down these two conditions. So for the first condition here, the start time can be less than the end time of slot B. But in the case where it's like this, that's still a valid overlap. I think I'm overthinking this actually.
Yeah, there is a much simpler way if you think. The diagram that you made is correct. If you can just think like what you have to pick.
Oh, I think it's yeah. Maybe we should just check start time if it's less than or equal or less than the end time. Yeah, if slots A enter A in time is greater than slots B index pointer B start time, or B, B. For now, I'll write this for now, but if there's another condition I'm missing, I'll go back to it. So based off our logic, if they do overlap, we extract the max and the min. So max interval is max. Let's be more specific here. So the max start interval, max of slots pointer A 0 and slots B 0 min end interval was basically this, but flipped min end time for slots A and slots B. And then we should check if this is greater than or equal to the duration. Let me just go back on this. Okay, so yeah, we can return early because we want to return the earliest time slot that works for both of them. So if max start interval is equal to duration, return I think I saw that it returned a pair. Let me just double check. Pair represented by. Okay. So I think that should be okay. Okay. So that's if there's an overlap. If there's an overlap, then we increment one of the pointers. So let's see how we should do this. So if the end time of A is less than B, then we increment A. Less than the start time of B, and vice versa. So if so let's say pointer A, the end time of A is less than or equal to slots the start time of slots B, B 0. We're incrementing pointer A. So pointer A to the other way. B pointer B. I think that should be good to yeah, because I don't think there's ever a case where we need to increment both intervals together.
Okay.
Return an empty list if we reach the end. Are you okay if I test some example code?
I think so. For the conditions that you're checking for the overlap, can you revisit them? So what
Okay.
you're trying to do here is you're checking the first start, sorry, end of pointer A, right? Slot A,
Mm-hmm.
which is greater than start of pointer B.
Mm-hmm.
So let's say if the square was something like this, so this condition will still satisfy, right? And
No. Yeah, that wouldn't work.
yeah,
Okay, so it has to be between. Um, so between. Yeah, has to be between the B intervals start and end time. And likewise for the other one. So let's see, would that satisfy all of our requirements though? Well, the start time can be equal to the end time.
mhm.
Oh wait, no, that doesn't make sense. Sorry about that. So
Why it can be, right?
start time of pointer B can be equal to A.
Yeah, that can be.
So if it was like this, there's not much to.
But yeah, if you want to consider that case or not, that is another thing. But yeah, it can definitely be equal.
I think it could be equal to the end time of B. So that. But it can also be overlapping like this. The condition would still it's still between the end time, so that's still overlap. If we did this, that's still an overlap. That's an overlap, but this would satisfy this condition where the B end time is between the A interval. And then this again satisfies where A end time is between the B start and end time. Now, if it was in between like this, that still satisfies. Yeah, I think that's. I think that covers all the cases. Am I missing one?
Uh, Actually, there is a more simpler way to check, but I think this can work. Also, I have few problems here in the
Okay.
else conditions.
Okay.
So the slots A pointer underscore A ka first. So you are checking the end time, right? End time of
Yep.
slot A. If it is less than the start time of slot B,
Yep.
then you're trying to increment this.
Right. So, looking at line 27, 28, my example, if slot A's end time is less than or equal to slot B pointer B, um, it should be just less than. Just check the do the equals up here. So if it's less than, then should we increment pointer A to the next list, next interval?
Okay, so let's say if there is this, right? Something like this,
Uh-huh.
and your this condition doesn't satisfy. Let's say you found an overlap, but this condition doesn't satisfy. So will that mean like you will not move forward, or
Right, right. Oh, yeah, you're right. Regardless, we should increment something. Probably increment. So we should increment regardless. Um,
yeah,
we should increment the lower of the two.
yeah, no, it's correct. Yeah, you can probably get rid of elif also, like because you will always want to do pointer b plus one. Like if your first condition fails, that's just a suggestion.
Can you repeat that?
You can get rid of this. You can just do
Else?
else. Yeah. Okay. I'm still a bit skeptical about this check overlap, but yeah, let's try to run and let's see like if it satisfies all the conditions or not.
Okay. Okay. That's not that helpful. Okay. Let's see. 6, 12, 2, and 11. Yeah, I'm definitely overthinking the overlap part.
So think about this diagram, right? The diagram that you have made here.
Uh-huh.
So in this case, what do you want to pick? Let's take these two starting points, right? Starting point of A and starting point of B. If
Uh-huh.
there is an overlap, which point do you want to pick?
Starting point of B.
Right? And let's take the end part, right? So if there is an overlap, which point do you want to take?
Starting point, end point of A.
Yeah. So how do you get there? So if you want to write it in algorithm format,
Um, so so basically line 12 and 13 here.
yes.
I see. But if there's no overlap, so like this, we have there's no overlap. And we're still checking for the max start interval. Okay. Min and interval. If we're doing max start interval subtracted by min end interval, that would still give a number. So we should do a check after we do um there is overlap. Max start interval should be less than both end times. I feel like again I'm overthinking again. So
So if you take the max of start point and min of end points,
uh,
what is the relation between the overlap and not overlap? Uh, can you write it in mathematical format?
I'm not sure what you mean by that question. So if we
Okay,
have the min and max intervals,
right. So if you took the min max start interval and you take the min and interval,
uh,
then based on these two values, can you make a decision whether there is an overlap or not?
yeah, we can, but I feel like that logic would be just as complicated as the other one.
No, why?
Because then wouldn't we have to check if the max start interval is um, less than both the end intervals, and then vice versa? The max end intervals needs to be greater than both start intervals or
See,
equal to.
so this is one case, right? Then there can be this case. Uh, let's take this, right? Then there can be um, this case,
Oh,
right? And then there can be
right.
the reverse one, right?
So it has to be greater than the min of. So the max start interval has to be greater than or equal to the min of the start intervals, and then vice versa for the end time. So does that make sense?
Sorry, what you said?
The so we're getting the min of the start time, the max of the start time, and the min of the end times. But the max of the start time has to be greater than or equal to the min of both the start times, and the minimum end time has to be less than or equal to.
No, again, you're overthinking. So let's take. So if you take max of start time and min of end time, then if they both overlap, then max of start time should be less than min of end time, right? You can check
Yeah.
this for every conditions now here.
Oh yeah, that's pretty okay. So in this condition, max of start time is less than min of end time. In this condition, max of and start time is less than min of start time.
Min of n
Max
time.
min of end time. Okay, yeah, that makes sense. But it feels like not overlapped. Oh my gosh. Okay.
Yeah, it's okay.
And
So actually, you don't have to write any statement like this code is itself correct now.
yeah. Oh, I see. Oh man, I always overthink all these.
It failed or what?
Yeah.
Oh, it should be min of n time
Oh,
minus max. Yeah.
yep. Yep. Hmm.
This statement, I think.
Is it less than equal to?
No, this should be.
Oh. Oh. Huh.
Oh, it failed. Okay. Oh yeah. There was one mistake I forgot to tell you. So in the question it was asked you to give a time slot, right, in which they can have meeting. But what you are returning here is max start interval and min an interval. So this
Uh-huh.
can be greater than also your duration.
It can be.
Greater than
Can you
the
speak? It has to be greater than duration.
Yeah, it has to be greater than duration. Yeah, it's
Uh,
fine. It should be equal to. Yeah, it should be. Sorry. It should be equal to, but the result that you're returning, right? It should
uh-huh.
be equal to exact duration that you want to propose.
Oh. So it'd be max start interval plus duration.
Yes. Yeah.
Okay.
Now it has.
Yeah, that was good. Yeah, I totally overlooked that.
Yeah. Yeah. Actually,
Okay.
I just forgot. I thought like I will tell you, but yeah, then I forgot.
Yeah, thank you. Yeah, I got
Yeah.
a lot of stuff to do.
Yeah. Yeah. You got the logic correct, but yeah, I think you messed up in the overlap
Yeah,
thing. Yeah.
yeah, just overthought too much.
Yeah.
Okay.
Yes. No problem. It
Thank you.
happens. Yeah.
That was very helpful.
Yeah. So you're studying or you're working?
I work and I study, so I'm trying to move jobs right now.
Oh, switch the jobs. So you're based
Hmm.
out in US or
Yes. Yeah.
oh,
How
nice.
about yourself?
So yeah, I'm in India and
No.
I'm also working right now. So, but yeah, like I'm not planning to switch right now, but yeah, just
Oh,
as practice stuff. Yeah.
nice.
So where do you work? Like,
I work at Northrop Grumman, it's a government contractor.
oh, okay.
Yeah, but I'm trying to switch to like big tech.
Oh, nice, nice, nice. Yeah. Okay. Chalo,
Yeah.
then we'll
Good luck.
meet
Good luck
again.
with everything. Yeah. Thank you.
Yeah. Thank you so much. Bye bye.
Bye.